out. The probability of one user is the probability of one user is 1 minus the no users, because it said at least one, bless you. So we had to say that 1 minus a user is the no users, because it's the complement. So 1 minus the no user to the fourth, because it said choose at least 4 of them, and it's going to be 0.525. All right. Let me cover up.
Could you splash back to where you were real quick?
Absolutely. Y'all, we're going to be on vacation this time next week. Oh,
So next week is our vacation?
next week is our vacation.
So we don't come at all next week?
None at all next week.
Okay.
None at all. And then when we get back, we have 4 weeks left.
Okay.
We can do anything for 4 weeks. The distribution of Honor Society members at a local high school is shown below. We draw a student's name at random. What is the probability that the student is a junior?
You do add up all under the total column and then do 112 divided by total.
So these are juniors. These are 30 honor students out of the juniors.
Wrong.
These are 20 of the 125.
So you would do 30 out of the 112.
Okay.
No, I was right the first time.
I don't know. Y'all decide.
What, can we
Because it's not
Can you
asking
scroll up for a
about
second?
the honor society, it's asking about what like class they are in school. So you have to have.
I just want to know if they're a junior.
Yeah, so the
They're
total of everybody.
So I want to know, are they a junior? So what makes me happy out of total is what I want to know.
So the 112 over everybody.
So 112 is what makes me happy. Do y'all agree?
Yeah.
Now, where am I going to get my total from?
Adding up the.
So tell me numbers.
449. 92 plus 112 plus 125 plus 120.
Correct. Because this is really a double dip of that, because it's 20 students out of the 120. There's 125 sophomores, and 20 of those people are in the Honor Society. Yay? So I just want to know juniors. So there's 112 juniors, and these are the total number of students. So that is 112 out of 449, which is 0.249. All right, let's go to the next one. Did I bring the cute chart? No. Let me bring the cute chart. Clone. What is the probability that a student is a senior given that the student is in the National Honor Society? So, given means we have our binoculars on. We're not looking at everybody. We're only looking at the Honor Society students. So, probability of what makes me happy?
Senior.
That you're a senior given National Honor Society. So what is my top number going to be? What word?
37.
Senior. What's my bottom number going to be? Word. National Honor Society. So give me a number,
37.
37. Tell me numbers.
37 plus 30 plus 20.
So, given means I'm only looking at National Honor Society. From the National Honor Society, I only want to know the seniors. So I'm only looking at the National Honor Society. And from that National Honor Society, I only want to know the seniors. And I accidentally slipped over that by accident. All right, in the game text twist, 6 letters are given and the player must form words of varying lengths using the letters provided. Suppose the letters in a particular game are blah, blah, blah. How many different arrangements are possible using all 6 letters? What are we going to do? Combination or permutation?
Combination.
Permutation.
Is that a different answer than that?
Yes.
So does order matter?
Yes.
They're going to give you 2 different answers. So, what kind of problem is this?
Permutation.
Permutation. How many letters am I using?
6.
And how many letters are there?
6.
Or we can say 6, and then we have 5, then we have 4, then we have 3, then we have 2, then we have 1, so that would be 6 factorial, either way. How many arrangements are possible only using 4 letters? What would that be? How many letters do we have to start with? How many letters do we have to start with? 6. NPR? 4.
Oh, so you still have 6 letters, but you're only
Using 4 of them. So like one of your answers could be C-I-N-H. One of your letters could be C-I-S-E. So you're only using 4 of the 6 letters. You don't have to use all of them. The solution to the game has 3 6-letter words. To advance to the next round, the player needs at least 1 of the 6-letter words. If the player simply guesses what is the probability that he or she will get 1 of the 6-letter words on their first guess of 6 letters. Read through it again. All right, our question is, what is the probability that he or she will get 1 of the 6-letter words on their first guess of the 6 letters? So probability means what makes me happy over total. So, our total is going to be 6-letter words, and she gets all 6 correct. So what's the chances, or how many combinations or permutations or sample space of choosing 6 letters and getting 6 correct?
720. So 1 out of 720.
So it says that she has 6 letters and she has to get all 6 of them right, which was our part A answer. And the probability that she does that is a 1 out of 720. So there's 720 ways that she can get it right, and she's going to get 1 of those 720 choices. Which is probably not going to happen because that's a 0.4 if she just guesses.
But that says 3 over
yeah, it's-
720.
There are 3 solutions. The problem says there's 3 solutions. That's why it's 3 over 720.
I did not read. That's what I get for, where was it? Has 3.
There should be at least
3. Still has, 0.4. Yeah, it has 3 solutions. My bad, did not read the 3. All right, oh, I love this one. I don't want to read this since I'm going on a cruise next week.
Oh, gosh.
Yeah. But this is the actual survival information. How many males survived and died, and how many total males were on the ship. How many females survived and died, how many children survived and died, and the total that survived and died. So this was the total number of people on the ship, okay? So we're going to use this. What is the probability that a passenger survived? What is the probability that a passenger survived? Survived is going to be 711.
Over 2224.
2224. Go with me? That one's pretty easy, right? All right, and then I wrote it out kind of for you. Now, I made it, I don't know if you can see that, make it a little bit bigger. What is the probability that the passenger was female?
425.
Female, 425,
Over 2224.
2224.
425.
It's there. Bad. All right. What was the probability that the passenger was a female or a child? Female or a child?
So
Female or a child?
425 plus 109
425 plus 109.
over 2224.
Now, usually when we say or, remember, most of the time when we say or, it looks like this and it looks like this, and we do all the shading. Well, this time, it didn't overlap, but we're still going to do all the shading. They just didn't overlap. We good? What was the probability that the passenger was a female and survived?
316. 316 over
Female survived, and because it has the word and, that means we're looking at the overlap. That's our 316. Our total is the 2224. Now, if it would have said or, it would have been 711 plus 425 minus the 316, which is our double dip. Oh. Never mind. Female or survived is going to be 711 plus 425 minus the 316, which is our double dip, divided by the 2224. Because we counted that twice. Yay? Or you can say, I don't want to look at my totals, and you can say this plus this plus this plus this if you don't look at your totals. Either way. What is the probability, if a female passenger is selected at random, what is the probability that she survived? I didn't use the word given, but I'm not talking about everybody right now. I'm just talking about a female passenger. So what is my bottom number going to be? It's just going to be female. So I only want to know the people that survived out of the females. So my blinders are just on the females. So how many survived of the females? 316 of the 425. So for this one it says I only want to look at the girls, which is 425, and 316 of those survived. So 74% of the females survived. If a child is selected at random, what is the probability that the child survived?
57 over 109.
57 over 109. So we want a survived out of just the child. So we are only looking at the children and the ones that survived. So 52% of the children survived. If a male is selected at random, what is the probability that a male survived? 338 out of 1690. So this is survival of the males. 20% of the males survived. So 20% of the guys survived, 52% of the children survived, and 74% of the women survived. So my next question says, do you think the adage, women and children first, was adhered to on the Titanic? 20% of the males survived, 50% of the children survived, and 74% of the women survived. So when they say women and children first, that's what they did. They put the women and the children on the lifeboats first, and the men stayed on the drowning boat. So the women and the children had a higher survival rate because the men put them on the rafts first, and the men went down with the boat. So 20% of the men lived. What was 52.3% of the children lived, and 74.4% of the women lived. So that is showing you that the men did put the women and children off the boat into safety first, and the majority of the men died. Because they took care, I know, isn't it sad?
It's so sad.
They took care of the children and the women first and put them to safety. So that's why we always say women and children first. Suppose that 2 females were randomly selected. What is the probability that they both survive? So we're doing 2 probabilities. The probability of a woman and the probability of a woman. We're picking 2 people now. What's the probability that the first person was a woman? Say it, girl. We want to survive a woman. So 316 out of 425. Now, because once you pick a woman and she survived, you can't pick her again. She's already off the boat, she survived, we picked her. So that number goes down, so 315 out of 424. And we can't pick a dead woman, we gotta pick a survival woman. So if we wanted to interview somebody, we could pick a surviving woman, interview her, and then pick another surviving woman. All right. That is it for 5, 6. Now, let me pick, say, we can get started a little bit in,
Can we look at that homework before we move
oh,
on?
yes. Let me, where'd that go? What section was it in? 5?
Yeah, 12.
Number 12. Let me, I'm gonna put it in 6-1's homework. Since I just closed out 5, 6. 6-1. Close, get my snippers. Copy. 1, 2, 3, or to 4 effective. 1 minus the complement, which is what I was thinking. 1 minus 0. Let's see. Let's copy 6-1 and move up, paste. Double check it before I explain it. Forward effective, which that means that 126 are good. .8812 what the answer?
It said it was wrong. I'll have to check again real quick, but that's why I was confused, because I thought, like, I didn't think the one or more would make it a difference. Yeah, no, it's .8812 is wrong.
Okay, hold on. Here, work on this one. You're good at this. 4 out of 4 are good. Hold on, what did I do? Try .1188.
Yeah, that was right.
Okay. Okay, so for this, and what number is this? This is 5.5, number 12. All right, y'all, because you're gonna have one like this on your homework. Suppose a shipment of 130 electronic components, so there's 130 total. 130 total, T-O-T-A-L. 4 are defective and 126 are good, that makes 130. To determine whether a shipment is to be accepted, a quality control selects 4 and tests them. If 1 or more is defective, it's rejected. What is the probability that it's rejected? So, this is accepted and this is rejected, so that's why I did the 1 minus.
Okay,
So I started out by doing the accepted.
okay.
So I did,
So you would do it, the .88, 1 minus the .88, whatever, so you do it the same way, you just
Mhm.
have to do the 1 minus.
so I did, the probability of picking 4 defective. Randomly selects 4 and tests them. Okay, I'm picking 4 good, is what I'm doing. So, that's gonna be, if I pick 4 good, these are good ones. Let me do good and bad over total. Okay, I'm picking 4 total out of 130. Okay? I'm picking 0 bad, and I'm picking 4 good. So how many are the good ones? I'm picking 4 good ones from how many good ones?
126.
126, and I'm picking 0 bad ones from the 4 bad ones. And you really don't even have to write this part. Okay? So I can just do this over this. I'm picking 4 from the 126 good, and I'm picking 4 out of the total. And when I do this in my calculator, I end up getting the .8812.
Yes.
But that represents accepted. And it says, what is the probability, where's my question? What is the probability that it's rejected? So the rejected is going to be 1 minus the accepted, which is 1 minus the .8812.
Okay.
And that's where we're getting the final answer of .1188.
Okay.
Yep. So yeah, it's set up the same way, they just
You
ask
have
you
to
for the
do
other
that.
thing.
Okay.
Yeah. All right. Section 6.1 it's a slight change, but it has a couple of the same things that we've been talking about. Discrete and continuous. Discrete, remember, is like shoe sizes and hat sizes and pant sizes. Continuous means it can be any number in the book. So, the time it takes for a light bulb to burn out. Give it to me. Continuous It can be infinite values. It can take 4 hours, 36 minutes, and 29.25 seconds. The weight of a T-bone steak. They say continuous because if you put it on a fancy scale, it could weigh 1 pound